alpha will also be the matrix of some line S of space beta, which will be in the direction of alpha in space beta. Thus, if the lorry halts at some point P of space alpha which lies on the line R, it is now moving along the line S of space beta. This is the theory of relative motion. The common matrix is the bond which connects the motion of beta in space alpha with the motions of alpha in space beta. Motion is essentially a relation between some object of nature and the one timeless space of a time system. An instantaneous space is static, being related to the static nature at an instant. In perception, when we see things moving in an approximation to an instantaneous space, the future lines of motion as immediately perceived are rects which are never traversed. These approximate rects are composed of small events, namely approximate routes and event particles, which are passed away before the moving objects reach them. Assuming that our forecasts of rectilinear motion are correct, these rects occupy the straight lines in timeless space which are traversed. Thus the rects are symbols in immediate sense awareness of a future which can only be expressed in terms of timeless space. We are now in a position to explore the fundamental character of perpendicularity. Consider the two time systems alpha and beta, each with its own timeless space and its own family of instantaneous moments with their instantaneous spaces. Let m and n be respectively a moment of alpha and a moment of beta. In m there is the direction of beta, and in n there is the direction of alpha. But m and n, being moments of different time systems, intersect in a level. Call this level λ. Then λ is an instantaneous plane in the instantaneous space of m, and also in the instantaneous space of n. It is the locus of all the event particles which lie both in m and in n. In the instantaneous space of m the level λ is perpendicular to the direction of beta in m, and in the instantaneous space of n the level λ is perpendicular to the direction of alpha in n. This is the fundamental property which forms the definition of perpendicularity. The symmetry of perpendicularity is a particular instance of the symmetry of the mutual relations between two time systems. We shall find in the next lecture that it is from this symmetry that the theory of congruence is deduced. The theory of perpendicularity in the timeless space of any time system alpha follows immediately from this theory of perpendicularity in each of its instantaneous spaces. Let ρ be any rect in the moment m of alpha, and let λ be a level in m which is perpendicular to ρ. The locus of those points in the space of alpha which intersects m in event particles on ρ is the straight line r of space alpha, and the locus of those points of space alpha which intersects m in event particles on λ is the plane 1 of space alpha. Then the plane 1 is perpendicular to the line r. In this way we have pointed out unique and definite properties in nature which correspond to perpendicularity. We shall find that this discovery of definite unique properties defining perpendicularity is of critical importance in the theory of congruence, which is the topic for the next lecture. I regret that it has been necessary for me in this lecture to administer such a large dose of four-dimensional geometry. I do not apologize, because I am really not responsible for the fact that nature, in its most fundamental aspect, is four-dimensional. Things are what they are, and it is useless to disguise the fact that what things are is often very difficult for our intellects to follow. It is a mere evasion of the ultimate problems to shirk such obstacles. End of chapter 5.